So in this video we are going to develop an end-to-end machine learning project which is BigMart sales prediction. So this is gonna be the basic life cycle of our machine learning project. So first thing is how we collect the data. The data can be found here. I will provide the link in the description. So here are two files, test.csv and another is a train.csv. I had downloaded it already and store it in dataset folder. So first of all, we will install the libraries that will be essential to our project. First one is a pandas profiling, which we will use to create a report of our data. Then another is a scikit-learn, which we'll use to train our data. I had already installed it, so I'm not going to install it again. So first of all, we will import the libraries that are pandas, numpy, pandas profiling. So after that, we will load the dataset. The dataset is stored in dataset, and inside our dataset folder we have train and test. So we are storing that data into a train data and test data. So after that, let's look at the train data. So this is how our data set look like. So it has item identifier, item weight, then the fight content, then the visibility of that item, then type of that item, then MRP, then the information about the outlet. So here item outlet says that is the output that we are going to predict. So let's describe our train data. So these are the some description of our data. So let's look at the information of our data. So it contains integer and object and float values, and some of the features have null values. So this is just raw data. So we have to process that data. So in data processing, we will concatenate the data. So it has train data and test data. So first we will label the train data as a train and test data as a test. After that we will concatenate the data into data. And here we are ignoring the indexes. So after that, let's see size of train data set, test data set and the combined data set. So here you can see our data set has been combined. So let's look at the data. So here one more column has been added, that is a source, which indicate the source of our data, which is a train or test. So let's look at the tail data. Here are null values in the item outlet cells. So because it is of test data. So let's count the null values. So here you can see item weight having 2439 missing values, then outlets size has some missing values and item outlet cells. So let's count the percentage of null values. So these are 17%, 28 and 39. But if you can see in item outlet cells, it had 39% of null values. It is due to a test data. So we are going to fill the, so here item weight has 17% of null values. So we can fill that by a mean value or mode value or by a median. So first we will check it has some outliers or not. So if we draw a box plot of item weight, so here you can see there is no outliers are present. So we can fill it by a mean value. So for a better accuracy, we are going to map the item weight with the item identifier. So first check the unique values of item identifier. So these are the some unique values of item identifier. So then we are going to draw a pivot table which will map the item weight with the item identifier. So let's check out the item average weight. So here are the average values corresponding to an item identifier. So let's define a function which will compute the weights of an null values and that will fill into a null values. So here we are defined a compute weights as a function name. So here first is the weight, which is the first column, and identifier is the second column. So first we will check that weight is null or not. If it is null, then we will map our weight with an item identifier in a pivot table. If it is not null, then we will return the same weight. So let's run this function, and after this let's fill out the null values. So here data of item weight. So here we are going to pass two columns, that is item weight and item identifier here, that are defined here. So we are going to apply a function compute weight with axis is equal to 1 and data type will be a float. So in this item weight and item identifier will pass to a compute weight, which will compute the mean values using the mean value corresponding to an pivot table in item identifier. So let's check out the null values in item weight. So here we can see there are zero values that are null. So another column with null values, which is outlet size, that can be filled with the mode value. So here also we are going to draw a pivot table with the mode values of an outlet type. So here I had defined a variable outlet size mode, which will be create a pivot table of a outlet size and outlet type, and the aggregation function will be a mode. So let's check out the outlet size mode. So here you can see there are four outlet types. That is a grocery store, supermarket type 1, type 2, and type 3. Here mod value of a grocery store is small, type 1 supermarket is small, type 2 is medium, and type 3 is also medium. So here also we are going to define a compute size mode, a function that will going to compute the null values of an outlet. So first is the size and another is a type. So here we are going to pass two columns, that is a size and type. So column of 0 will be a size and column of 1 will be a type. So here we are going to check that value is null or not. If it is null, then we will fill the value with the mod value of a pivot table. If it is not null, if it is not a null, we are going to return the same size. So let's fill out the values. So data of outlet size we are going to modify, and here we are going to pass two variables or two columns, that is outlet size and outlet type, and we are going to apply a function compute size mode with the axis of 1. So let's check out the null values that are present in outlet size now. So here you can see now there is no null values that are present in outlet size. So all the null values has been removed from our data set. If we closely look at the data, there are 6.2% of values of item visibility have a zero values, which is does not make any sense. So we are going to handle that values, because the item visibility can't be a zero. That should be a something value. So here also we are going to draw a pivot table with the item visibility and item identifier, because that are corresponding to each other. So let's see visibility item average. So here these are the some visibilities corresponding to an item identifier. So we are going to fill that zero values with the average value of item visibility corresponding to that item identifier. So we had defined a function compute visibility mean, and here also we are going to pass up columns that are item visibility and item identifier. So first one is the item visibility and another is the item identifier. So if visibility is 0, then we will going to return the average value corresponding to that item identifier. If it is not 0, then we are going to return the same visibility. So here we are going to compute the visibility, and we are going to pass two variables, that is item visibility and item identifier, and we are going to apply a function compute visibility mean that we have defined here. So here axis is 1 and our return type will be a float value. So let's run this, and let's see the sum of item visibilities that are zeros. So now there are no values that have values 0 in item visibility. So there is another column. Here you can see outlet establishment year, which actually does not make any sense. That can be anything. So we are going to create a one column which will be specify how many old is that store. So actually that data set is from 2013. So we are going to divide that year from 2013 and create a new column which is outlet years. So let's describe our outlet years. So these are some description of our outlet years column. So let's create another broad category of item type. So here you can see item identifier having values FDA 15, DRC 01 like that. So that FD means food, DR means drink, NC means non-consumable. So this indicates the what is the type of that item. So we are going to create that another column that will be specify the item. So here we are just capturing the first two characters of our item identifier, which is IFD, DR. Here also IFD like that. So in data of item type combined, we are going to just capturing the first two characters. Then we are going to map our data with full form of that characters. That is FD means food, NC means non-consumable, and DR means drinks. Then we are going to count the values that are food, non-consumable, or drinks. Here you can see food is 10,000, non-consumable is 2,000, and drinks are 1,000. So here you can see another column item fat content, which is low fat, irregular, low fat. So we are going to change the category. The some values in the item fat content column are yellow, low fat, and both, and all the things are same. So we are going to replace that value with our only a single value. So data of item fat content, we are going to assign a value item fat content, and we are going to replace the values of ELF means low fat, and there is a low fat in a lowercase. That also we are going to replace with a low fat. Then another is a regular, which is a regular. So let's count the let's assign the values and count the values. So here low fat values are 9,185 and regular are 5,090. So there are non-consumable that should not be included on low fat or fat content. So we are going to replace it with a non-edible content. So first we will assign a values of non-consumable fat content with a non-edible. So let's count fat content values. So here you can see now. So here you can see there are only two values before low fat and regular. Now we had three values, that is low fat, regular, and non-edible. So let's transform our features. So that's a common sense that if item visibility will be more, then our sales of product will be more. So we are going to create a one function which is item visibility function, which will be compute the mean ratio of item visibility. Here we are going to pass item visibility with an item visibility average ratio. So we are going to create another column item visibility mean ratio, and here we are going to pass item visibility function and our return type will be a float. So let's run this, and now let's see how our data set look like. So here you can see item visibility mean ratio, which will indicate ratio of our item visibility with a mean. So let's describe our that column item visibility mean ratio. So these are the some values. So let's handle the categorical variables, because here you can see there are so many categorical variables that are item identifier, fat content, item type, outlet identifier, outlet size, location type, outlet type. These are some categorical variables that we can't pass to our machine learning model. We have to convert that values into a numerical form. So first we'll encode it using a label encoder. Then if you see here are some columns of our data set. So we are going to apply a label encoding on our categorical data. So these are the some variables of our data set. So let's check out the categorical variables. So first is the item fat content, then outlet size, outlet location type, outlet type, and item type combined. That we are going to transform and apply label encoding on them. So let's apply this. So let's check out our data. So here you can see item fat content has been converted to some numerical form, such like outlet size, outlet location type, and outlet years and item type combined, that are converted into a numerical form. So here are some values that has been assigned to that variables. So it is assigned by using alphabetical order. So if it is low fat, it will be 0, non-edible 1, regular is 2, such like that. So we are going to apply a one hot encoding on item fat content, outlet size, outlet location type, and item type combined. So first thing is when to apply label encoding and when to apply one hot encoding. So first thing is label encoding will assign the values on the same variable or a same column, but one hot encoding will be create a different columns by assigning numerical values like 0, 1, and first thing is when to apply which method. So we can use a label encoding when there is a relation between uh, the variables of that column, like there is a good bad, there is some relationship, right? So we can assign the values like 0 and 1, 2, like that. But in one hot encoding we can't clearly say the relation between the variables. We can apply a one hot encoding when there is no relationship between the variables of that column, like the names of any two persons. There can't be any relationship, right? So there we can apply a one hot encoding. So it will be create different columns. Suppose there is a male and female that are two variables in that column representing a gender. Then if you apply one hot encoding, that it will create two columns of male and female, which will be indicate values of 0 and 1. So let's apply one hot encoding. So let's check out the data types now. So here you can see all the numerical values are there, that are float and integers. So here you can see some are object that we are going to remove from our data set. So let's delete some unnecessary columns, that are item identifier, item type, outlet identifier, and outlet establishment year, because we had modified that data in our data set. So let's partition our data in at the starting of our project. We had concatenate our data with the source of train and test. Now we are going to partition our data, which is train data frame and test data frame, with the label of source, that is train and test. Then we are going to drop our source column, which is not necessary for now. And in a test data frame we are not going to use a test outlet size which is not necessary in our test data frame. So we are going to remove that also. So let's check out our train data and test data. So here you can see all the values are in numerical form that we had done by label encoding and one hot encoding. So if you check about the test data, there is no column of item sales. So that's we had removed from our test data. So we are going to save our data frame that we had modified by using a data processing, and we are going to store that data in train modified.csv and test modified.csv in our dataset folder. So if you check about our dataset, here you can see test modified.csv and train modified.csv. So now let's create our EDA report from our modified dataset. So here we are using pandas profiling to create exploratory data analysis of our dataset. So here profile report is a function in which we are going to pass our train data frame and the title of store sales prediction and explorative is equal to true. So it will create a report and store it in profile variable. So let's store that report in our HTML file. So it will be render our report into a HTML file. If you want to see that report in our notebook, that can also see by to notebook underscore iframe. So report has been generated and it is now rendering to our HTML file. So that also has been done and it has been exported to our HTML file. So here in our Jupyter notebook also we can see our report. So here if you check out data set has number of variables are 22, that observations are 8523, then also missing values, duplicate values, then of each variable it will show all the description of that data. So here you can see item visibility, MRP, item outlet size, outlet years, all the values has been described here. So if you check out our HTML file, so here EDA report has been generated. So if you open it, here you can see that report here overview, variables, interaction, and also a correlation between the variables as can described here, that auto, then spearman also, then pearson, all the correlations has been described here, and all the missing values are described, then the sample of our data set has been described. Actually pandas profile so much reduced our work of EDA to actually create an report of our dataset. So moving to our next part. So let's read our modified train data. So it is we have stored that our modified train data in our train data mod. Then we are going to drop the outlet size and for x value, that is we are going to create two variables x and y. X is that means the features of our data set and y is our output. So for x train mod, we are going to drop the item outlet size, and for y train data we are just going to pick up the item outlet size, that is input and output. So let's look at our x and y values. So that's look great, and outlet size, or if you see output is also stored here in y train model. Now let's split our data set into a train and test. So here we are going to use a scalar dot model selection, and here there is a function called as train test split, which will be used to our which will be used to our split our data into a train and test. Train data is used to train our machine learning model, and for evaluation purpose of our data set, we are going to use a test data. So we had imported our train test split. Now we are going to split our data into two forms, that is train data and test data, which is X train, X test, and Y train and Y test. So here we are going to pass our X train and Y train modified data. So here we are passing X train mod and Y train mod, that are X and Y variable, that is features and output variable. So we are going to apply a random set of 101 and test size is 0.2. 0.2 indicates 20% of our data set will be going for test and 80% will be a trend data. So let's split out the data. So splitting our data has been done. So we are done with the splitting of our data. So it's time to train our model. So we are going to use a random forest model to train our data. So from sklearn.ensemble we are importing a random forest regression. We are importing a random forest regressor because this is a regression problem, and we are going to use random forest regressor. So let's import this, and let's create an instance of our random forest regressor, which is in the regression underscore ref, and we are going to fit our extend and white trend data to our regression model. So we had stored our data and fitted our data into our model. So let's check out our score of our model, that is the accuracy of our random forest model. Here we are passing X test and Y test. So here if we check out the accuracy, it is nearly a 53%. So let's check out the predicted values of X test. So we are storing that predicted values into a Y-pred variable, and we are going to create an histogram of Y test and Y predicted. So here you can see that the values are normally distributed over here, and let's check out the scatter plot of these values of Y test and Y predicted. So here you can see the accuracy is quite good, not bad actually. Now let's check out the accuracy of our model by using a mean absolute error, mean square error, and RMS values. So first we will import the matrix from scalar. Then we are going to print out the values of mean absolute error, MSE, and RMSE. Here we are passing two values, that is Y test and Y prediction. So here you can see mean absolute error is 788, mean square is like this, and RMSE is 1119. It's time to improve the accuracy of our model. It is nearly a 53%, right? It was 53%. So let's do some hyperparameter tuning on our model. So because of randomized search CV is fast, so we are going to apply that on our model. So first we'll import our randomized search CV, that is a cross validation from our model, from our SQL and model selection. So here we are defining some variables, that is n estimators. It is having a 12 values from 100 to 1200. Then the number of features to consider at every split. Then the max features will be auto and square root. Then we are going to define the depth of our random forest. Then the sampling split and the sample leaf. After that we are going to pass that number of variables to that our random grid, and we are going to pick up the best parameters, and we are going to train by using that best parameters. So we are here. So here we are going to create a randomized search CV by using that values that we are defined here. So let's fit our data now. So it is doing a 5 folds of 10 candidates. In total are 50 feeds. So it will be take some time to our fit our data and picking out the best parameters from our estimators. So fitting has been done. So let's check out the best parameters of our random forest. So estimators will be a 300, sample split will be 100, sample depth will be a 5, max features will be auto, and the max depth will be a 50. So let's predict the X test values. Now let's check out our auto score. So here you can see the score is 59%. So initially that was 52%, right? Now accuracy has been improved by a cross validation. Now let's draw a histogram. So here you can see the histogram of X test and the predicted values. Now let's draw a scatter plot. So you can see the data set has been so much compressed to one line than the before. So let's check out our score of R2, MS, R2 score, MAE, MSC and RMSC. So R2 score is 59%, min absolute error is 7.3, MSC is 11 lakh, RMSC is 1051. So now we have developed our machine learning model. Now, if you want to reuse our machine learning model, we have to store it anywhere, right? So we are going to store it in our pickle file. So we can just read that model and use in our any application. So first we will import the pickle library that we are going to use to store our machine learning model. Then we are going to open a file which is rfmodel.pickle and it will be a writable. Now we are going to dump our information of our RF model into a file. Then we are going to close our file. So we are store our model in our rfmodel.pickle file. So here you can see that file has been created here. So now let's predict our test data. So we can read our machine learning model using like this, and we are going to store that model in model variable. So let's check out the test data. So this is our test data, and we are going to predict the outlet size. So here we are going to predict the outlet sales by our model that we are storing a pickle file. So here we are going to create another variable which is item outlet sales, and here we are going to predict the values that we are going to pass to that our model, and we are converting that values to a list. So let's check out the our data frame. So here another column has been created which will indicate the outlet sales that we had predicted by using our machine learning model. Now we will store our output or data frame into a CSV file in our dataset folder. So the syntax will be a testdf dot to CSV and the path of our CSV file, and our indexing will be a false. So we are done with our creating our machine learning model. So that's all for today guys. Thank you so much for watching this video.